this. Separation and identification of group 1 cations. Group 1 cations you can just remember as happy thallium warp. I repeat, happy thallium warp. H stands for Hg, mercury in +2 state. A stands for Ag, silver in +1 state. P stands for Pb, lead in +2 state. Since there are 2 P in happy, you just remember as Pb is in +2 state. Next, thallium in +1 state, tungsten in +6 state. In many of the reference book, they would mention tungsten in +6 state as tungstate anion. Why it is so? There is some fact. See, all the metal ions are either soluble in water, hot water acid or hot acid. Exceptional case is your tungsten. Tungsten is neither soluble in water nor in acid. Okay. So to make it soluble in the presence of oxygen, you can read the fact above. In the presence of oxygen, this tungsten metal was ignited, and during the process, what was obtained? Tungsten trioxide was obtained. And this tungsten trioxide, it was then fused with sodium hydroxide in something called iron crucible to form the tungstate anion. Now this tungstate anion is water soluble, so that you can prepare your original solution and further you can get into your analysis. Is that clear? Now this group 1 cation is group 1 reagent I have written in square bracket. All the content written in the square bracket, you can view that as a reagent or the step to be done, and this double hash indicates the residue part, and the single hash indicates, okay, the single hash indicates your centrifugate or filtrate, like that. Okay, now assume your sample contains your group 1 cations, right? You are just assuming. So on adding this group reagent dilute hydrochloric acid, cold dilute hydrochloric acid, you may get the white PPT. Clear? You may get white colored PPT. If white is there, then it can either be mercurous chloride, silver chloride, lead chloride and thallium chloride. Clear? Now if you are getting yellow color, it is simply tungstic acid. Tungstic acid is formed. Okay. Now what you do is, previously you added cold dilute hydrochloric acid, again you add cold dilute hydrochloric acid in order to ensure that all the group 1 cations are precipitated. If any group cations are left behind, in order to precipitate them again, we are adding this cold dilute hydrochloric acid so that it would be precipitated and the other cations will stay in the centrifugate part. You should do centrifugation here too. If the centrifugate, you can discard it or you can add to the previously collected centrifugate. Is that clear? Now once you have done the washing with the washing liquid, now you boil the precipitate. You should add some water, boil it. Why to boil? Because this lead chloride and thallium chloride are soluble in hot water, and that is the reason why we are boiling it with water. And when it is hot, when the sample is hot, you should do the centrifugation very quickly so that your centrifugate will contain the lead or thallium ions. Clear? Okay. On doing centrifugation, you are collecting the centrifugate, but the residue still remains in the still remains white or yellow. Okay, then that means it can either be mercury or silver. Mercury in +2 state or silver in +1 state. Okay, if you are getting a yellow residue, directly means that tungstic acid is present still. You can directly go to the confirmatory test given below. Confirmatory test, in that collect the residue. You just acidify with hydrochloric acid, add tin to chloride, stannous chloride, boil it. You will get a blue colored precipitate, that is the oxide of tungsten, or otherwise you can perform another confirmatory test to the residue. Just add ferrous sulfate. Upon adding ferrous sulfate, you will get ferrous tungstate, which is brown in color, and to which you just add hydrochloric acid. Brown will change into white. On heating, white will be converted into yellow. Okay, if yellow residue is present, for sure it is a tungsten and +6 is present in your sample. Is that clear? Okay, if you are getting a white colored precipitate, What was the previous reagent? Hot water. Again you just wash with hot water in order to remove lead and thallium. Okay, just to make everything perfect. Okay, again we are washing the residue. Do centrifugation. Centrifugate is either discarded or added to the previously collected centrifugate. Okay, now you add the reagent called ammonium solution. Since we are adding ammonium solution, here we are acidifying with hydrochloric acid. Okay, if not, if you are not adding ammonium solution, you can omit this step. Directly you add stannous chloride and you will see this blue colored PPT. Okay, on adding this ammonia solution, mercury will react with that to form mercury and mercury amine chloride. This mixture is black in color. If you are getting a black PPT, you can confirm the presence of mercurous in +2 state. Mercurous ion is present in your sample. These are the confirmatory tests. To the aqua regia soluble. It is aqua regia soluble. After dissolving it, you just add potassium chromate. Potassium chromate is yellow in color. On adding that, you will get red colored mercury to chromate you will get. And if you are adding another confirmatory test is in alkaline medium, this mercury in +2 state will give you mercurous oxide. Clear? Which is black in color. So this will confirm the presence of mercury in +2 state. No, you are not getting any black PPT. You might have collected the centrifugate, isn't it? In the centrifugate, centrifugate will contain water soluble diamine silver chloride. Okay, chloride it is water soluble complex. Then tungstate anion. So to this you just add potassium iodide. If you are adding potassium iodide, you will get this anion. This cation will react with this anion to form silver iodide. Silver iodide is pale yellow in color, which is soluble in sodium thiosulfate. After dissolving the PPT, you just perform these confirmatory test, which will confirm the presence of silver in it. Okay, just add potassium chromate. You will get silver chromate which is red in color. Okay, this one I have already discussed. Now coming to this part, the centrifugate. Okay, the centrifugate, that means your lead and thallium, if it is present in the centrifugate, upon cooling the white PPT reappears. On heating, white PPT disappears. On cooling it reappears, on heating it disappears. If it is so, there will be lead or thallium. If nothing, any white PPT is not present or any white PPT doesn't appear on cooling, then lead and thallium is not present. You can proceed with the other group analysis. If it reappears, you just heat it and you add sulfuric acid. On adding sulfuric acid, lead with sulfuric acid form lead sulfate, which is white colored PPT, which is soluble in ammonium acetate solution. After dissolving it, perform the confirmatory test. Easy only. You just add potassium chromate, you will get turbid yellow. If you are adding potassium iodide, you will get potassium. Potassium iodide if you are adding, you will get lead iodide, which is bright yellow in color. With ammonium sulfide, it forms lead sulfide, black in color. All these things confirms the presence of lead. No, if you are not getting a white PPT, but on cooling, white colored PPT reappears, it might be thallium. So now you have added sulfuric acid, right? In order to neutralize that, you can add either ammonia or sodium thiosulfate. After neutralizing this medium, you just add potassium iodide. You will get thallium iodide, which is yellow in color, insoluble in sodium thiosulfate. Here you see, this is soluble in sodium thiosulfate, this is insoluble in sodium thiosulfate. Okay, and one more confirmatory test is thallium with potassium chromate will give you turbid yellow again, which is now insoluble in nitric acid. Lead chloride is soluble in nitric acid. Thallium chloride is, chromate. Lead chromate is soluble in nitric acid. Thallium chromate is insoluble in nitric acid. So this is a point of difference. One more thing you can do, that is the flame test. Flame test you should do, you know, right? You take the sample, add concentrated hydrochloric acid, make it as a paste, dip it in platinum wire and introduce in the Bunsen burner. You will get green color. For one more cation, green color appears, and that is barium. Now how you can conclude whether it is thallium or barium? If that is the question, you can do spectroscopy analysis. If you are getting a single sharp line at 535 nanometer, it is thallium. If you are getting several lines around 510 to 550 nanometer, that is barium salt. Is that clear? Thank you.